through my project on personal health and fitness data collected by my iPhone and by my Apple Watch. And I had the question of what factors influence my sleeping heart rate, because my sleep tracking app had been telling me last year on certain nights that my heart rate had been really, um, not really high, but higher than I would have expected on certain nights. And I was wondering what was um, causing that on those nights, because I couldn't figure out any correlation on my own. So the data available to me is listed here. Each of these are included in their own CSV file, and follow the general same paradigm of formatting. However, there are notable differences. Sleep analysis and heart rate will be the most important data sources. So the first thing I did was to clean up and manipulate this data. So I started here with my raw data. This is the table. The start and finish columns are just plain character values, which reveal for one row the start and end time that the value is referring to. And this, in this case, is just a numeric value for the heart rate, but in other data cases, this would be whatever data the table is referencing. Something unique about the heart rate table, though, is that these times can overlap. So here we have multiple rows which are at 1334 starting and ending. And I had to figure out what I was going to do with that. So I decided to average all conflicting times, um, average their values together. And so we move on to the next table where I have grouped by date time, um, joining this to a table that includes the full range of date times from the first entry to the last entry, including one row for every minute, even uh, if there's no data entry for that time. And what I do is I do a fill command where I fill down so that 68 here is transferred to this row, but we copy it down until we have another entry. Um, and here we have the grouped by date timetable. From there, we move to grouped by date, where we do a similar thing. We ignore the times and then have one row for every day in our date range. And with the heart rate, I turned this row into one of four different things, being mean, median, max, or min heart rate for that day. And I would utilize each of those tables for different things. And from there, I also made another table where I grouped by weekday. And these are just the means of all Sundays values, in this case, heart rate. Another table I made was grouping by time. So this took all entries, in this case, heart rate entries at 12 a.m. of all days, and averaged them together and put their values here. And I'll show the charts made from this one later. Another table I made for only a couple of data types was this grouping by both weekday and time of day. And here I used the pivot wider command because the joining process gave me a column including the weekday. So I got to use that in order to make more columns and fewer rows. So the other important piece of data I have is the bedtime data, which this is the raw data again. We have our start time and our end time, and we have two different rows: the minutes in bed and the minutes of sleep. The minutes in bed are populated for almost every night, and this is done by my phone by the clock app. So it happens more often than minutes of sleep, which happens by my sleep tracking app, which I don't do every night. So we have a lot of zeros in this row. So I won't do a whole lot with this data here. But from here, I split it into two different tables, one showing or one containing times when I went to bed, and um, and this one including times when I got out of bed. And for getting out of bed, I put the in bed column to being false, and when I get in, it's true. And then I merged them together, and again, I filled down so that I have this table, which shows me for every date time whether or not I was in bed. So I take that table and this table that I made a little while ago with the heart rate, and I do an inner join on them so that their date ranges only include where they intersect. And from there, I make this table, this important table, the bed heart rate table, which shows me for every date time um, that I'm asleep or that I'm in bed, it includes only those heart rates. And from there, I can group again by date time, by day, and by weekday. And it will include only, um, like if I group by date, then it'll show me only the heart rate, the mean heart rate for while I was asleep. All right, so the next thing I did was I had a lot of fun with visualizing my data. And this was less for the purpose of answering my final question and more for the purpose of understanding general patterns about sleep and fitness and different things. So I used this library, Google Viz, in order to give me access to the Google Charts API, which gave me cool things like this year plot. And these are only pictures. I'll show the interactive version in a second. But right here we have um, those three different tables I just talked about. This is the heart rate mean um, table, so it's grouped by date, not by time or date time, but date. And then over here we have the grouped by date bed times, and we can see that we have far more data on the bed times than on the heart rate. So when we do the inner join, we get the intersection of those two ranges, both starting at this period of time. And this table here is one of the more important tables to me because it shows me that during these times at the end of the semesters, I am far more, when I'm far more stressed, I also have a higher sleeping heart rate, which um, doesn't correlate to any of my hard numbers, but does confirm a suspicion I had that um, I did sleep with higher heart rates when I was um, at school, as opposed to these times when during quarantine and during Christmas breaks when I have a notably lower sleeping heart rate. So what this does when I run the command in R is it opens these up in my browser, and it gives me this nice interactive view. So here I have the flights climbed. That's one of the data, flights of stairs climbed. I have this nice interactive view, and I can put my mouse on any one data point and see what the date is and see what that value is. And something interesting about this chart is it shows me pretty much the exact times I leave and enter Taylor because I live on 4th Garrick when I'm at Taylor, and I live in Texas on a single story home the rest of the time. So this is when I moved on to Taylor. This is the Christmas break. This is when I came back to Taylor. This was when I was. This is during the summer, Christmas break again, and quarantine again. So this is helpful because it helps me confirm the reliability of at least this data, and again points to how nice it is to work with personal data because you can utilize your own background knowledge of the information to verify it. This is something I'll talk about later. After this slide. So these are two different charts that group by time. Up here we have bedtime. So when I'm in bed, I group by time, and down here we have heart rate. So we can see that I go to bed around this time, which is like midnight right here, and then I start waking up again around 7. And then heart rate again, I can see even while I'm still asleep, my heart rate starts increasing around this time, certainly when I wake up, and then a little higher through the end of the day, and then down again when I start going to sleep. So these are grouped by date, but this chart that was just looking at, this one right here, is grouped by date and also by weekday, and reveals some interesting information about my sleeping habits because in this case we show Sunday being the night that I would wake up on Sunday. So this is actually Saturday night, and this is Friday night. And we can see Saturday and Friday nights I go to sleep consistently or on average later. But then also on Sunday morning consistently sleep in later, and same on Saturday, but then weekdays I'm pretty much always waking up earlier. So this is very beneficial having the interactive data because I can see um, what, for one, like what line this is because I'm colorblind and this key isn't much help for me, but also showing me the different data or the different times for that specific point. Um, and the cool thing about this library is it works with Shiny, which I don't know how to use. I didn't have the time to learn, but that could make for some pretty powerful data visualization pages, putting multiple things together and making them even more interactive. All right, so I made some other cool diagrams. These are just histograms showing the distributions of different variables. This is the heart rate. Kind of just gave me more information about where things were at, helped me understand my data. These are my weekday charts, which showed me some pretty cool insights about how um, how I'm different on different days of the week. Sundays are consistently less action, less um, or lower mean heart rate, lower maximum heart rate. Whereas Monday, Wednesday, Fridays, these are the days that I work out. They have higher maximum heart rates, higher calories, and everything. So again, confirming to some extent that the data is reliable. So now we finally get to where I seek correlation for these variables. So the first thing I do is I build this giant table, which I call my calendar because it has one row for every day. And it has all of my different variables in a different row, which makes for a lot of NA values because a lot of, like, I don't go biking every day, so we have a lot of empty values. And here's where I start adding my rolling mean columns, which uses this zoo library. And what this is for is to see, or to give me the data available to check trends for sleeping trends, where I can, so like what the rolling mean will do is it'll, this is going to be the mean for the last 4 days at this time. The next column is rolling mean 6, and that'll, or 8 actually, and that'll show me the rolling mean, or the mean of being in bed for the past 8 days. And I'll be able to use that to correlate with my sleeping heart rate. So I ran a bunch of different correlation matrices and started picking variables that I would include in my final correlation. So up in the top left, I'm going to have the bed heart rate, and then here I'm going to have the variables I'm considering. So for heart rate, I'm not going to include any of these because they inform this value, but maximum heart rate does not, so I can use it because I'm not going to be achieving my maximum heart rate while in bed. And then this is all the different sleeping data. This is where I put in my rolling means just to see if there were any kind of correlations. I can look at this column here to look for correlations. And I do see potential correlations, but they're not very strong. So I am going to include bed and sleep, but I didn't really know which one of these to use. So I ended up running a correlation manually on each of these, and ultimately the rolling bed for 24 days turned out to have the most influence, so I chose that one. And then finally, these activity correlations show, first of all, something very notable is the high correlation between miles and steps, which makes sense, but reveals that I only really need to use one of these values. So I chose miles, but we also see here that there is a possible notable correlation over here between miles and the heart rate. Nothing as clean as over here, but we see a distinct lack of data down in this corner over here, which could be informative. And then I also chose to include active calories just because that was something that's the correlation here isn't too obvious or present, but it was something I was wondering about whether that would influence that behavior. So here's where I finally build the models. I built 2 models. One was a linear regression model using the formula bed heart rate is proportional to these variables we just looked at. The linear regression model ended up coming up with these coefficients, not all of which make sense. The most significant one was the rolling bedtime, or bed hours, or minutes actually, which had a negative 20 coefficient, which means when I spend more time in bed over a 24-day period, then my heart rate will be negatively influenced. It'll be lower. However, this I was not expecting to see a positive value for in a particular day. Spending more time in bed would increase my heart rate. However, when I thought about it, it did make sense potentially for the reason that once I stay in bed later, I'm able to go into later sleep cycles where my heart rate might increase. Again, this is me just speculating though. I'm not a sleep expert, so I don't actually know. And then these other variables were not super influential. Sleep was about as influential as bed was, just in the actual negative direction. So down here I have the distributions of the errors when I tested the linear regression model on training data, or on testing data, which is separate from the training data. And to see the mean is relatively close to 0 with these values for the quartiles. Then I also made a decision tree model, which I'll show on the next page. This is the distribution for the error of that model. And this finally is that decision tree, which reveals different significant factors than the linear regression model. It shows first here the split being between miles. So traveling or walking / running less than 5 miles was determined to be influential in lowering the heart rate. And then after that, active calories, after that, the rolling bed time. And you can go all the way down here. But this ultimately is kind of what I was going for, and does reveal, as far as the accuracy of this model goes, the correlation between activity and increasing that sleeping heart rate. And yeah, that's all I've got.